Samsung Electronics and SK Hynix have been testing equipment from a Chinese semiconductor tool company called Advanced Microfabrication Equipment Inc., or AMC.
Right. Specifically, their etching tools.
Yes, they are specifically testing AMEC's etching tools. And on the surface, testing a new piece of hardware sounds like a routine procurement event. The data in front of us, however, points to a fundamental shift in the risk calculation of the customer on the factory floor.
Because it is not just a hardware trial, it is a calculated response to shifting global trade policies.
Exactly.
The economic complication of export controls is that they create an immediate divergence in priorities. I mean, look at the macroeconomic intent. A trade restriction is designed by policymakers to deny access to sensitive technology. It is meant to increase costs for advanced processes and ultimately slow down a competitor's technological progression.
That is the intended macroeconomic effect, yes.
Right. But the manager overseeing a semiconductor fabrication plant does not operate on a macroeconomic timeline. Their immediate non-negotiable problem is entirely different. They have to keep the production lines running tomorrow morning.
We need to examine the specific economics of that factory floor to really understand the continuity risk. Because semiconductor factories are built entirely around the concept of unbroken operation. The capital expenditure required to make a modern fab is, it's staggering, often running well over $10 billion just for the facility and the clean rooms alone.
And the critical financial metric there is the depreciation clock.
The depreciation clock runs continuously. It is amortizing those billions of dollars every single day, whether the production line is yielding advanced memory chips or sitting completely idle.
Which is why that continuous financial pressure makes the concept of an equipment ecosystem so central to this analysis. An advanced lithography or etching machine is not a standalone piece of hardware.
No, the sale of the machine is only the beginning.
Precisely. The procurement of the tool is merely the beginning of the commercial relationship. The equipment operates within a tightly integrated ecosystem. You have process recipes, predictive maintenance algorithms, continuous software support, and dedicated field service engineers.
To put a specific metric on the value of that ecosystem, ASML generated more than 8 billion euros from installed base management in the year 2025.
8 billion euros.
8 billion euros generated solely from servicing and upgrading machines that are already operating inside customer facilities.
Right.
Which leads us to a framework we need to look at. Policy-adjusted total cost of ownership.
The traditional procurement model in a semiconductor fab evaluates a new tool based on a few set things: purchase price, yield percentage, uptime, throughput, and maintenance costs over a 10-year lifespan.
But today, procurement officers must adjust that calculation by adding a policy risk discount to the incumbent tools.
Well, let's look at the operational mathematics of that adjustment. What happens to the defect density and the overall yield if a fab manager decides to buy a cheaper domestic machine that produces fewer good chips per wafer?
Under the traditional model, it's financially unviable. A tool that lowers your output of usable chips just doesn't make sense.
It doesn't. However, a technically superior industry-leading tool from a Western supplier now carries that policy risk discount you mentioned. I mean, if a critical machine loses access to replacement parts, software updates, or those vital field engineers 3 years into a 10-year cycle, relying on a single restricted supplier transforms from standard operating procedure into an unacceptable continuity risk.
Which means a technically weaker second supplier is now worth qualifying, purely for the optionality it provides to the fab manager.
Optionality is the key word here.
Qualification is the hidden mechanism. Management cannot afford to wait until access to Western tools completely disappears to begin testing domestic alternatives. They must initiate the qualification process years in advance, just to ensure the production lines can transition if supply chains are severed.
Building on that concept of optionality, we can observe how this policy risk discount actually plays out in existing Chinese fabs that are owned by foreign companies.
Samsung and SK Hynix, for example.
Right. They previously operated their Chinese facilities under a regulatory framework known as validated end-user treatment. This status essentially provided a blanket authorization. It allowed these foreign-owned fabs to import controlled U.S. equipment without navigating the bureaucracy of individual export licenses for every single shipment.
That validated end-user treatment was removed. It drew a hard regulatory line around the expansion and upgrading of those specific facilities.
Now, the immediate problem created by this policy change is not the sudden closure of the plants. The existing equipment can continue to run.
The systemic issue is long-term capital planning. Board directors must decide whether to commit billions of dollars in future capital expenditure to a geography where the servicing environment, say 5 years out, is entirely uncertain.
We can compare the option value of two hypothetical fabrication plants to illustrate this trade-off. Consider Fab A, located in a jurisdiction with predictable, unrestricted access to next-generation equipment and engineering support.
Okay.
Now consider Fab B, an identical facility producing the exact same chips, but operating under recurring policy uncertainty regarding future equipment procurement. The financial option value of Fab A is significantly higher because it possesses a clear pathway to upgrade to the next technology node.
Whereas Fab B faces a high probability of aging into obsolescence.
Exactly.
This uncertainty effectively redirects future investment capital away from restricted jurisdictions without necessarily forcing immediate plant shutdowns.
And that points to the central analytical paradox we are looking at. The very policy that makes a Chinese fab less attractive for future foreign capital investment simultaneously makes domestic Chinese equipment more attractive inside that existing fab.
Because the foreign owners of the facility are securing an insurance policy, they face uncertainty regarding the maintenance of their existing Western machinery, so they are actively qualifying second-source domestic tools to ensure the plant remains operational.
Which brings up the second major framework. Fab containment can coexist with supplier development.
A policy can successfully restrict a specific facility from advancing to a smaller nanometer node containing its capability, but it simultaneously forces that same facility to purchase domestic equipment, thereby aiding the development of local suppliers.
It is essential to recognize that industrial substitution within a fab occurs category by category. It is a fallacy to state that China has successfully replaced Western semiconductor equipment across the board, but it is equally inaccurate to state that China cannot reduce its technological dependence until it replaces every single imported component. The reality is segmented.
We can observe that segmentation by looking at the engineering differences between equipment categories. As we mentioned, Advanced Microfabrication Equipment, Inc. focuses on etching.
Etching involves using specialized plasma chemistries to selectively remove microscopic layers of material from a silicon wafer. It carves out the complex architectures of a microchip.
It requires extreme chamber stability and precise gas flow. Deposition, conversely, involves laying highly uniform materials onto the wafer. Cleaning tools prepare the surface between steps. Lithography is the process of projecting light to put the patterns.
And the difficulty curve across those categories varies immensely. Extreme ultraviolet lithography, for instance, requires reflecting lasers off microscopic droplets of liquid tin to generate specific wavelengths of light, all guided by the flattest mirrors ever manufactured.
That represents a fundamental physics challenge that resists rapid substitution.
Right. Whereas etching and deposition, while highly complex, rely on chemistry and material science variables that domestic challengers can iterate upon much faster.
Which brings us to the operational byproduct of this category-by-category testing. When a manufacturer like Samsung or SK Hynix tests an AMEC etching tool as an insurance policy, they are providing that supplier with an invaluable asset.
Real-world production learning.
Yes. Real-world production data. Young equipment companies face a structural, circular problem in normal market conditions. They need demanding, high-volume customers to prove the reliability of their machines.
But those demanding customers strongly prefer to purchase proven machines with a decade of reliability data. The geopolitical uncertainty forces the customer to break that cycle and test the unproven alternative.
And testing those alternatives directly provides the domestic supplier with high-volume data on failure modes. When a machine processes thousands of wafers in a continuous production environment, the supplier learns exactly which ceramic seals degrade first, how chamber pressure fluctuates over time, where software anomalies occur.
That data leads directly to better calibrated parts inventories. It leads to vital engineering adjustments for their next-generation machines. We are looking at a self-reinforcing feedback loop.
Qualification of a tool leads to initial procurement orders.
Those initial orders expand the supplier's installed base inside the fabs.
A larger installed base generates the steady service and maintenance revenue required to build a robust field infrastructure.
And that recurring revenue funds deeper R&D, resulting in better equipment, which subsequently makes qualifying for the next generation of manufacturing significantly easier.
The speed of that feedback loop is heavily influenced by state capital. The data explicitly notes that the third phase of China's National Semiconductor Investment Fund was registered with 344 billion yuan of capital.
344 billion yuan. Now, providing capital does not automatically generate precision engineering, but 344 billion yuan fundamentally changes the sheer number of attempts a domestic industry can finance.
The strategic advantage of this industrial policy is not rooted in identifying and picking a single guaranteed corporate winner. The advantage lies in financing enough broad experimentation across the sector.
It effectively aligns the incentives of the entire domestic ecosystem. The domestic customer requires alternatives to mitigate operational risk. The government provides 344 billion yuan to aggressively incentivize localization. The supplier gains access to both capital and production data.
And to be clear, the customer is not intentionally attempting to build a future global rival. They are simply acting to reduce their own supply chain vulnerability.
The result, however, is identical.
So if domestic alternatives are receiving unprecedented capital and generating real-world production data, we have to assess how this impacts the strategic timeline and the balance sheets of Western incumbents.
The two clocks model frames this dynamic quite well. The first clock is the restriction clock. This measures the time bought by denying a competitor access to a specific technology.
And the second clock is the substitution clock. This measures the speed at which the restricted ecosystem can create an economically usable alternative. It doesn't even need to achieve performance parity with the leading Western tool. It merely needs to meet the baseline yield requirements of the fab.
The primary variable affecting the speed of these two clocks is allied coordination. If one nation restricts the export of a specific tool, but an allied nation permits the export of a near-equivalent tool, the customer will logically substitute toward the allied vendor.
The customer avoids the cost and delay of developing a domestic alternative.
Conversely, broad international coordination across allied nations effectively closes those alternative procurement avenues. It intentionally forces indigenous development and accelerates the substitution clock.
The financial exposure for Western incumbents operating under these broad restrictions is substantial. We must look at the specific revenue dependencies. According to the numbers, China represented 30% of Applied Materials' fiscal 2025 revenue, which equates to about $8.5 billion.
30%?
Yes. And for Lam Research, China represented roughly 34% of their fiscal 2025 revenue.
Well, I will interject to clarify the long-term impact of those figures. While losing a significant portion of regional revenue is absolutely a material headwind, it is a severe oversimplification to conclude that Western companies will be forced to drastically reduce their research and development, or that they face an existential threat.
The global semiconductor market continues to expand independently of these regional restrictions.
Precisely. The structural demand for artificial intelligence infrastructure is driving significant capital expenditure globally. We are observing massive government subsidies being deployed in the United States, Europe, Japan, and Korea to build new, localized fabrication capacity.
Therefore, a Western supplier may experience a decline in market share within restricted geographies, but simultaneously capture the newly subsidized capacity emerging in Texas, Arizona, or Germany.
The total addressable market is shifting geographically, but the underlying demand for the equipment persists. The core investor question regarding the balance sheet is not simply the loss of regional revenue. It's the threat of moat erosion by category.
And moat erosion depends entirely on the behavior of the customer after the initial qualification phase. Analysts must watch to see if Chinese domestic suppliers win repeat orders, or if they successfully move their tools into foreign-owned fabs operating within China.
The ceiling on this expansion is largely dictated by intellectual property and security constraints. A highly sensitive manufacturing process requires deep integration with the equipment. A foreign fab may be highly reluctant to grant a domestic tool vendor access to its proprietary process knowledge.
So based on the data, the geopolitical and market outlook for 2030 points toward a state of layered competition rather than a cleanly bifurcated global market.
Western, Japanese, and European equipment suppliers are positioned to remain dominant in the frontier choke points. Technologies like advanced lithography that require decades of compounding physics research and remain highly resistant to rapid substitution.
Simultaneously, Chinese equipment companies are expected to gain significant market share in selected mature categories like etching, deposition, and cleaning, utilizing the production data gathered during this current wave of qualifications.
The procurement calculus has fundamentally changed. Equipment companies historically competed on three primary metrics: technology, cost, and service. Moving forward, they will compete on a fourth metric: policy reliability.
Policy reliability.
The winners in this realigned market are suppliers in non-restricted jurisdictions who absorb the shifted capital expenditure alongside domestic challengers who secure the production necessary to iterate their designs.
And the losers.
The losers are the margins of the incumbent suppliers. They suffer category-by-category mode erosion and lose long-term pricing power as second sources mature into primary sources. The ultimate strategic vulnerability highlighted here lies in the weaponization of a dependency, which inherently forces capital to aggressively search for a viable substitute.
If you want the unlayered global to follow the next layer of this semiconductor system, tell us which matters more. Controlling the technology competitors need today, or remaining the supplier they still choose tomorrow. Because the strongest monopoly is not the one a government can temporarily protect. It is the one customers keep choosing even after they have qualified an alternative, and that is the long contest export controls cannot avoid.